Hi everybody. Today we're just going to practice coming up with equations for lines and line segments like medians and perpendicular bisectors. So you might be given a question like this. Determine the equation of a median from vertex A in the triangle ABC as given. Okay, so whether you put it on a grid or not, always a good first step is to kind of draw out an approximation of what this triangle might be. Let's see, -3, -6. Doesn't have to be beautiful, doesn't have to be perfect, but should kind of look like what you want. So finishing off with C at -5, 3. -5, 3 would be something like this, I guess. C, -5, 3. And I'll just sketch in some sides to this triangle. And of course, the question tells me that I need a median from A. So I knew that I need a line that's coming, a line segment that's coming from A and going to, according to the definition, the midpoint of B and C. So the first thing I'm going to do is I'm going to calculate the midpoint of BC. So I'm going to use my midpoint formula. I'll just write it in one time, x1 plus x2, y1 plus y2, 2. Again, it doesn't matter which one I call x1 and y1. We'll just do this one, x1, y1, this one, x2, y2. And so let's plug in the numbers here. -5 plus -3. 3 plus -6. And that equals -8/2. And -3/2, which works out to -4 and -1.5 if I prefer that to -3/2. Now, whenever I have a calculated value when I'm working on problems like this, and I have a drawing, I make sure that my answer makes sense. -4, -1.5. Would that actually fit in this line? Well, -4 would be, yep, halfway between those two. -1.5 would be somewhere just a little bit down there. So yeah, that's a believable point, that the midpoint of BC is -4 and -1.5. And so I'll just draw in that median. There she is. And we'll proceed. So we're never losing sight of our ultimate goal, which is to find an equation. Right? An equation, and we know that linear function equations are in the form y equals mx plus b. And in order to come up with that, we need the following information. Either we need both the slope and a point on the line that we have, or we need 2 points. Now, here's a situation, I think, where because we figured out the 2 endpoints of our median, we have 2 points. We use 2 points to find the slope. Slope goes in for m. And then we sub back in one of the points and solve for b. You've been doing this since grade 9. Shouldn't be too much of a hassle to do this. So, finding the slope of our line from a to m, y2 minus y1, x2 minus x1. So 1 minus -3/2, which is what -1.5 is. 5 minus -4. 1 minus -3/2 is 1 plus 3/2, and then 1 is the same as, by the way, as 2/2, if that helps me. 5 plus 4. We'll keep going. That gives me 5/2 on top, 9 on the bottom, and this is 5/2 times 1/9, right? 9. This is a fraction over a fraction, or a fraction divided by a fraction. I know the 9 doesn't look like a fraction, but of course any number is a fraction if you put it over 1, and dividing by a fraction is the same as multiplying by the reciprocal. So just to finish off, sounds complicated, but it's not really. We have 5/18, and I think that's in lowest terms. Looks like my slope for this median is 5/18. So I'm going to take my slope and I'm going to sub it in, sub that slope in, and here we go, y equals 5/18 x plus b. And now I'm going to sub in a point, and I can take a or m. I like a, it doesn't have any fractions, so I'm going to sub in a, which is 5, 1, which means that I'm putting 1 in for y, and 5 in for x, and I get 1 equals 25 over 18 plus b, therefore 1 minus 25 over 18 equals b. Well, 1 is the same as 18 over 18, that's easy enough. Now it looks like it's negative 7/18 for b. So I have everything I need, therefore the equation of the median is y equals 5/18 x minus 7 over 18. Now I'm not done until I look at my picture and I say, is that reasonable? This is kind of a slope. It's for sure has to go up in that direction. It's a positive slope. It's kind of flat because it's a low number. Hey, this one's kind of flat. This is a number that's less than 1. It's less than a half even. So is my line crossing somewhere between the negative half area? Yeah, this equation here is reasonable for my drawing. And if I were to quickly do this up in GeoGebra and take a look at it, there it is. Not bad. Okay, in this example we have to find the equation of a perpendicular bisector in another triangle ABC. So I'm going to quickly sketch this out. A is over at 7, 1, we'll call it there. B is negative 5, negative 3, something like this. And C is negative 2 and 4, something like that. Okay, and join, and there we go. Okay, so I need a perpendicular bisector. That means that's a line that runs through the midpoint of AC and it runs perpendicular. So let's first figure out where that belongs. I want to know what the midpoint of AC is. x1 plus x2 over 2, y1 plus y2 over 2. We'll call C x1, y1, we'll call A x2, y2. Doesn't matter which one is which, as long as the 1's are together and the 2's are together. So when I sub all the numbers in, I get something like this, and I think this simplifies to 5 over 2 and 5 over 2. That's handy. And just, if it helps me, that's 2.5 and 2.5. Again, does that look reasonable? Is this about 2.5 over and 2.5 up? Something like that, I think, is correct. So we'll call that right here, midpoint of AC, and at 5 over 2, 5 over 2. So great, I know the location of the midpoint. I know where that line is going through, and I can actually sketch it in. It's got to go something like this, right? What do I know about it? It's got to be perpendicular, okay? So, and I need to come up eventually with the equation, y equals mx plus b. Now, last time I told you there's two possibilities. Information I needed to calculate the equation of the line is either a slope in 1 point or 2 points. Here I've got 1 point, and I don't know how I'm going to find any other points. I also don't have a slope for this, and I also don't know how I could calculate the slope for this. But what I do know is this. This line is perpendicular to this line, and I know how perpendicular slopes work. I know that if two slopes are perpendicular, then the slopes are negative reciprocals of each other. And so if I know the slope of AC, I can use that to figure out the slope of my perpendicular bisector. So, first thing I'm going to do is determine what is the slope of AC. Slope always equals y2 minus y1 over x2 minus x1. Fill in some numbers here. 1 minus 4 over 7 minus negative 2. 1 minus 4 is negative 3. 7 plus 2 minus negative is this, and in lowest terms that's negative 1 over 3. Why did I find this slope? Because I need this slope. What's the relationship between two perpendicular slopes? They are negative reciprocals. So the slope of my perpendicular bisector is perpendicular to the slope of AC. Therefore, the slope of my perpendicular bisector is the negative reciprocal of negative 1 over 3 and it equals 3. Technically it works out to 3 over 1, but 3 over 1 is 3, and plane 3 is easier to work with. Okay, y equals mx plus b. I'm going to sub in that m equals 3, and y equals 3x plus b. I need a point. Hey, I've got a point. I'm going to sub in that midpoint of AC because I know that that's going to work. And so 5 over 2 equals 3 times 5 over 2, the x and y happen to be the same, plus b, and some calculating here. So 5 over 2 equals 15 over 2, plus b, subtract the 15 over 2 from both sides, and I got 5 over 2 minus 15 over 2 equals b. That's negative 10 over 2 equals b, and I've got that b must equal negative 5. And if I put all this information together, then I can conclude that my perpendicular bisector has the equation y equals 3x minus 5. And again, I check that out, okay? What does this slope say? Oh, it's a positive slope that's kind of steep. That kind of checks out. Does it look like it might be going through negative 5? Yeah, that's reasonable that that's negative 5. So this equation looks good for the perpendicular bisector. Therefore, the perpendicular bisector through AC is y equals 3x minus 5. And maybe I punch it into GeoGebra and see if GeoGebra agrees with me. And I'd say that looks pretty good. All right, there you go. Finding equations of medians, finding equations of perpendicular bisectors, using all the information and all the skills that you learned last year to find equations of lines, just applying them in new places.